Hello guys, can you hear me? Am I live? Check it once. Am I audible to you? Sangli people, am I audible guys? Please let me know through the chat box. Am I audible? My screen is visible to you? I'm launching the technical poll. Oh my God, no, it's created. Fine. Okay. Am I audible to you? Please do respond in the chat box. సరే ఫోన్ మీరా క్లాస్ ఏది చేసి దేనికి థ్యాంక్స్ ఇది అవంతి కంపెనీ. Okay, so without wasting time, I would want to discuss you about some of the important factors, right? I don't want to waste much time on discussing which is unnecessary, right? So let me go through the, bond angle and the importance of it. I hope everyone can see my screen. Sangli students, please do respond in the chat box. Is this my screen is visible? Yes, in YouTube, one school joined now. Okay. I was waiting for the others to respond. It's 5-2 already. So I don't want to waste much time, guys. So I will start discussing this one. Okay. So now, basically bond angle, how do you decide a bond angle? In normally, angle, if you say for any particular geometry, so the angle is always calculated between two sides. So if this is side 1 and side 2, and these particular, the deviation among these two sides are called as angle. But whereas in chemistry, if you see, the bond angle is always calculated between the three atoms. So bond angle can always be calculated for the three atoms. Let's suppose if I'm saying BH2. So BH2 means the bond angle between hydrogen, beryllium, and hydrogen. So what is the bond angle between beryllium, hydrogen, and hydrogen? So that will give the bond angle. Let's suppose if I'm writing hydrogen, beryllium, and hydrogen. So the bond angle is 180 degrees. This is how you will write about the bond angle. But whereas if I'm seeing, right, so whereas if I want to find the bond angle for BH3, so BH3 you can have 3 hydrogens like this. Okay, so if I'm asking about the bond angle is simply nothing but hydrogen, boron, and hydrogen bond angle. So hydrogen 1, 2, 3. So the bond angle can be calculated like this. So this is 120, and here it is 120. Here it is 120. Okay, so in chemistry, basically what is going to happen in chemistry, right? So in chemistry, whenever we are calculating the bond angle, we calculated in between the atoms. So now you can see as the bond angle is decreasing, you can see the bond angle is increases. Okay, so we can say that the hybridization will be sp, sp2, and sp3. Okay, so ideally what I can tell, so if the bond angle, if it is sp hybridization, the bond angle will be 180, sp2 120, and 109 degrees. So different hybridizations will have different bond angles, and based upon the lone pair repulsions also, the bond angle will changes. So more will be the repulsions, more will be the bond angle. Let's suppose if I am adding here, so let's suppose if I'm drawing for the CH4. So CH4, you can see here the bond angle, you can clearly say from here is, okay, this is 109 degrees 28 minutes. So the bond angle between hydrogen, carbon, and hydrogen is 109 degrees 28 minutes. Now if I am seeing about NH3, you are having one lone pair on the top of nitrogen, and it is having a pyramidal geometry. Which geometry? It is having a pyramidal geometry. Remember guys, bond angle can never be calculated for the lone pair bond pair. So bond angle can never be calculated for the lone pair. Let's suppose if I want to find the bond angle between the lone pair and the bond pair, this is highly impossible because we can't predict the electron cloud here. So that's why bond angle never be calculated with respect to the lone pair. The simple reason because we don't know the exact dimension of the electron cloud and the influence of the electrons over there. So you can't consider a lone pair as a particular atom. Whenever bond angle you are calculating, you should calculate only between the central atom and the adjacent side atom. Okay, central atom and the adjacent side atoms. So now this is 107 degrees and this is 107 degrees. Yes, this is sp3 hybridization and this is also sp3 hybridization, but still the bond angle is different here. There is 2 degrees decrease in the bond angle. Why? Because of lone pair bond pair repulsions. Because of lone pair bond pair repulsions. If simultaneously, if you take for H2O, you are having what? 2 lone pair of electrons. Now, because of lone pair repulsions, because of lone pair repulsions, what will going to happen here? They will try to push the bonds downwards. So now the bond angle will become 104 degrees. So this is actually bent, or we can also say that bent V shape. We can also say that bent V shape, or you can also call it as angular shape. Bent V shape, or we can also call it as angular shape. I hope you guys are understanding to this. Okay. Yes. Okay. So the bond angle will be like this. So simple see baat, if the lone pairs are increasing, bond angle will be decreases. Very, very most important thing. First, what is the first factor you have seen here? First factor is very simple. That is hybridization can help in the formation of bond angle. So sp3, you will have 109 degrees, 28 minutes. sp2, that is 120 degrees. And sp 180 degrees. sp3d2, you will have 90 degrees and 120 degrees. Sir, can you show why this 90 and 120 degrees? Best example, if you take PCl5, phosphorus is here, chlorine, and this is called as equatorial plane. This is called as equatorial plane. And this is called as axial line. This is called as axial line, or we can also say axial plane. And 2 chlorines are at the axial line and 3 chlorines at the equatorial line. We call this geometry as trigonal bipyramidal. What you are going to call it as? Trigonal bipyramidal. Is it clear to you? Now the bond angle here with respect to the axial and the equatorial means if I want to find, this is the axial chlorine and this is central atom and this is the equatorial chlorine. This is equatorial chlorine and this is axial chlorine. So the bond angle is 90 degrees. Okay. So with respect to the axial chlorine and equatorial chlorine, the bond angle is 90 degrees. Next one, this is equatorial chlorine and this is phosphorus and this is another equatorial chlorine. So the bond angle between 2 equatorial chlorines is 120 degrees because these both are in same plane. These both are in same plane. So the bond angle is 120 degrees. I hope you guys understand this one. Is it clear to you guys? Right? Next one is sp3d2. Next one is sp3d2. So sp3d2, the bond angle is simply 90 degrees. How it will be 90 degrees? Let's suppose if I am drawing for SF6. If I am drawing for SF6, fluorine. So which will form a octahedron, which is form a octahedron. So one fluorine on the top, another fluorine on the bottom. So if you see here, the bond angle between these 2 atoms. So this is also again axial plane, and this is also equatorial plane. This is also equatorial plane. Are equally atoms have been shared. Okay, now if you see the bond angle among them is 90 degrees. The bond angle among them is 90 degrees. So with respect to the axial and this one. So total how many 90 degrees are there? 1, 2, 3, 4. Total 4 at the top, 4 90 degrees are there, and the bottom 4 90 degrees are there. Top 4 and bottom 4. So total 8 90 degree bond angles are there, and only 8 bond angles are there. Next one, if I can say, very most important, IF7. Next one is IF7, which we are also call it as pentagonal bipyramidal. What is that? Pentagonal bipyramidal. Pyramidal. Sir, how it looks like? Just draw a pentagon first. I am drawing one pentagon here. I am very bad in diagrams. Don't worry about this one, guys. So this is a pentagon. What happened? Yeah, this is a pentagon. Now you can see on the top one fluorine, on the bottom another fluorine. So these all are the fluorines. These all are the fluorines. So now everyone know that what is the angle in a pentagon? What is the angle in a pentagon? So if you don't know what is the angle in pentagon कितना होगा? अगर आप लोगों को पता नहीं है, it's very simple. Let's break it. So if you break this one, you got to know that the bond angle here is, this is a triangle and this is a square. This is a triangle and this is a square. So we know that total bond angles will be simply nothing but what? Total bond angle in triangle is how much? 180 degrees. But bond angle in square is how much? 360 degrees. If you add both of them, how much you are going to get? You are going to get 540 degrees. So the total angle, the bond angle in the pentagon is how much? So the bond angle in pentagon is 540 degrees. So now how many sides are you are having? 5 sides. So divide 540 by 5, you are going to get 108 degrees. So it is pretty clear that the bond angle between them is how much? The bond angle between them is 108 degrees. So if this is 108 and this is also 108, same 108, 108 and 108 is the bond angle. Okay. Now this is above the plane and this is below the plane. This is above the plane and this is below the plane. So that's why the bond angle will become what? 90 degrees. Here this is also 90 degrees. But the point here is like bond angle with respect to this. Now you can understand the bond angle with respect to this is how much? The bond angle is 72 degrees. So now the bond angle along the pentagonal plane is how much? 72 degrees. That is IFF. This is how much? 72 degrees. I hope you guys understand this one very clearly. Okay, so that is 72 degrees will be the bond angle. Okay, so next. So that is 72 degrees, right? Now, next if I move on, right? Next, if I move on, yeah. So lone pair repulsions increases, so bond angle decreases. Next is electronegativity. Very most important is electronegativity. So bond angle is directly proportional to the electronegativity. More will be the electronegative, more will be the shared pair of electrons, more will be the bond length, and more will be the bond angle. Let's suppose if I am talking about H2O, so H2O will have more bond angle compared to H2S. Okay. So nitrogen and phosphorus, nitrogen will have more bond angle compared to phosphorus. The reason because more electronegativity. Okay. So that is what you people need to remember. Size of terminal atom. Size of terminal atom increases, bond angle increases. So now if you see in this particular case, fluorine, okay, chlorine, oxygen and bromine. So these all are existing in OF2, Cl2O and Br2O. Okay, now here the side atom is fluorine, chlorine and bromine. Here where oxygen is common everywhere. Okay, as the terminal atom size increases, you can see fluorine, chlorine, bromine, the size increases. What will happen for the bond angle? Bond angle also increases simultaneously. PF3, PCl3, PBr3. So this is about the bond angles. Okay, now next. Bond energy. Bond energy, if you can see. Right. Now, if you can see the bond energy is depending upon the electronegativity difference. If higher the electronegativity is there, that will behaves as a ionic in nature. So now the ionic nature, we can also say if the electronegativity difference, if the electronegativity difference is more, then ionic nature is more. Ionic nature is more. Okay, ionic nature is more. Then simultaneously, what will going to happen? Bond energy is high. Bond energy is high because for the ionic interaction is an electrostatic force of attraction. So it required higher energy to break the electrostatic force of attraction. You might have get a doubt, sir, among ionic bond, covalent bond, van der Waal force of attraction, which is having a strong bond. Obviously, ionic bond is having more, bond strength compared to covalent bond and van der Waal bond. So, in case metallic bond is there, means metallic will come after ionic. Metallic will come after ionic. Metallic will come after ionic. Why, sir? Because in ionic bond, there is a strong force of attraction. In metallic bond, there is a strong metallic attraction will be takes place. Usually not itna strong nahi hoga. यहाँ पर repulsions भी ज़्यादा होगा. So there are repulsions will be favor. So more or less near to the covalent bonding and metallic bonding. So covalent bonding and metallic bonding ideally same hoga. Why the reason? Because inside the metal there are C full of electrons are there. So that is why the reason it will happen. Okay now. Next, bond strength. If I am seeing about the bond strength, so bond strength is simply depending upon what, which is having more electronegativity will have more bond stretch, or we can also say that bond strength, where it requires more energy to break because it acts as a ionic bond. Okay, so ionic bond is a trick here. Okay. Next one is bond order. Bond order, it can be calculated by the by the number of bonds. Here you can see the number of bonds is 3, 2 and 1. Here the number of bonds is 3. So the bond energy is higher for the triple bond compared to double bond and single bond. I hope you guys understand this one. Okay. And next one is hybridization of atoms. So hybridization is atom is simply nothing but bond energy is directly proportional to S character. Again, I am writing bond energy is directly proportional to the electronegative atom, which is more electronegative, that will form more ionic bond. More ionic bond means more strong force of attraction, and strong will be the bond. And it is directly proportional to what? Is directly proportional to the hydrogen halides. This one is what? Bond order. Bond order. So higher the bond order, more will be the bond energy, and directly proportional to percentage of S character. And we already know that if the percentage of S character is also decided by the electronegativity. More will be the percentage of S character, more will be the electronegativity, then more you require bond energy. I hope you guys understand this one. Okay. Right. Next. So next we are talking about the atomic size. Very most important is atomic size here. So now we know that from here we know atomic size of the bonded atoms. So we know that here you see chlorine is chlorine bonded, bromine bonded, iodine bonded. So same, if you see that atomic with the small atomic radius form the smaller stronger bonds, and the extent of overlapping is more. So now you can see chlorine is a smaller atom compared to bromine and iodine. So smaller the bond length, or we can say atomic radius, more will be the overlapping area, more will be the overlapping area, more will be the bond strength, more will be the bond strength, more will be the bond strength. Okay, more will be the bond strength. I hope you guys are clear with that. If the overlapping area is higher, then more will be the bond strength. Okay. Next one is extent of overlapping. Just now I am telling more will be the overlapping, more will be this one. Or we can also say that size. Size is also directly inversely proportional to the bond strength. जितना कम size होगा, उतना overlapping होगा, और उनका बीच में bond angle उतना सही होगा. Repulsions between the lone pair of electrons in the bond. So yes, repulsion should be minimum. Repulsions should be minimum. Why it should be minimum? Because minimum repulsions leads to maximum stability. Minimum repulsions leads to maximum stability. So that's why lone pair or whatever the lone pair of electrons or unreacted electrons, okay, they are will have minimum repulsions. Okay, they should have minimum repulsions and should have maximum stability. They should have minimum repulsion and should have maximum stability. Next one is dipole moments. Okay, very most important concept I will discuss. Then I will discuss this one. Right. Next one is covalent character. Let me discuss covalent character. Covalent character. Let me discuss about the covalent character. Sir, what is a covalent character? We know that there is no 100% ionic bond or covalent bond. There is no 100% ionic bond or covalent bond. Means something, if I am telling A and B is formed a covalent bond, A and B is formed a covalent bond, we can clearly say that it will have some percentage of ionic character, some percentage of ionic character. Okay, so let's suppose if it is forming A plus and B minus, it is strictly ionic bond, but still there is some percentage of covalent character, some percentage of covalent character. So how this covalent character decides and how much it is important for the examination point of view, today we are going to learn about it. Okay, today we are going to learn about it. Let's suppose what are the favorable conditions. Very most important, favorable conditions. Favorable conditions. Very most important. याद रखो. और यहाँ पर मैं कलर चेंज करना चाहता हूँ. Let's suppose for cation and next suppose anion. क्या होना चाहिए? पहले ये डिस्कस करते हैं क्यों आयोनिक कंपाउंड्स और कोवैलेंट कंपाउंड्स में आयोनिक कैरेक्टर डेवलप होगा. So covalent compounds also will have some ionic character. How? Let's see here. Okay, so or else we can also say some ionic compounds will have some covalent character. Okay, let's suppose this is a small atom A which is having a nucleus, and this is small atom, and next one is, which is simply say that sodium, or we can say Na plus. Next one is, so this is anion Cl minus, which is nothing but an anion, and this is simply nothing but cation. Now the electron which is present here, so under this nucleus, under the influence of Na plus nucleus, under the influence of Na plus nucleus, it will try to pull this electron. So whenever it is try to pull the electron, now the original shape of NaCl will become like this. Okay, so there is some slight shift in electron cloud. Okay, so you observe this one. What is happening? There is a slight shift in electron cloud is taking place. So where this is the electron, let's suppose. So it looks like some kind of sharing of electrons. Even though it is an ionic bond, but still some covalent character has been developed. Okay, so how do you find this covalent character? And this is called as polarizer. So that means it is polarizing the electrons. And this is undergoing what? This is undergoing polarizability. This is undergoing polarizability. Okay, so always remember, polarizer is a cation and polarizability will be under on anion. Okay, I hope you guys all are understanding this one. Next one, how do you find the covalent character? Finding covalent character. How do you find the covalent character? Very important. How do you find the covalent character? Covalent character, I am writing here. Covalent character is directly proportional to covalent character is directly proportional to charge on the species. Charge on the species. Example, if you are having Al plus 3 Mg plus 2 and Na plus. So we know that this is plus 3 charge and it will have more ionic character, more like undergo covalent character. Next one is anions. If you see anions, we can see Cl minus, okay, then Br minus, then I minus. You can also say that, but the same charge is same here, but the size here. So you need to consider the size factor here. You need to consider the size factor, okay, and the charge is +1 here. So then you need to see the size factor. So to be conclude, what I am telling to you is covalent character. To be conclude, what I am telling to you is covalent character can be decided by the anion and cation. Can be decided by the anion and cation. Now for the cation, if you can see for the cation, so for the cation, how it will looks like. So cation, it should have a smaller in size. It will have a smaller in size. It should be in the smaller in size. And second one, charge. Charge should be more. Charge should be more. ओके उसका चार्ज कैसा होना चाहिए, ज्यादा होना चाहिए. और इसका साइज क्या होना चाहिए, लार्ज एनायनिक साइज, लार्ज एनायनिक साइज. And what about the charge? Charge is also should be more. Charge is should be more. Okay, the charge should be more. So now let's suppose if I'm talking about LiCl, okay, LiBr, next LiI and LiF. If they have given this, if I am asking order of polarizing power, order of polarizing power, or we can also say that covalent character, also say that covalent character, also say that covalent character. So how do you calculate this one? How do you calculate this one? Now you can see, first write down what are cations and what are anions. Here cation is Li plus, which is a fixed one. So हमको इसको कोई जरूरत नहीं है. But the question here is like anion. So if you see the anion, anions are what? What are anions? Anions are I minus, okay, Br minus, Cl minus, and F minus. So this is the large size order. So what is this is? This is large size. Same क्या है यहाँ पर? Charge. Large is, charge is same, but the size is large. So that is why we can clearly say that LiI will have more covalent character compared to LiBr and LiCl and next LiF. I hope more is understanding this one. Okay, so covalent character can be decided by the large size of anion, very most important, large size of anion and small size of cation, small size of cation, small size of cation. Okay, I hope you all are guys understanding this one, right? Let me turn off the camera, guys. Okay, now let me give you some of the other examples like LiCl, NaCl, KCl, and CSCl. So if I am asking about covalent character, how do you find the covalent character? First of all, you need to write all the cations and anions. So now here cations are different. Cations are what? Different. How they are? Li plus, Na plus, K plus, and CS plus. Okay, these all are cations. So cations are varying. First point, and second one is their size is small. Size is small, very small. उनका size small है. तो अभी anion पर आते हैं. Anion में क्या देखा हमने? What we have seen? We are seen here Cl as a common one. So we should, they don't have any one. In case if there is any common anion is there, then their work will be common. Okay, common in the means of like they don't have that much influence on matter. So but now if you are seeing here Li plus, so this is having smaller in size, and next Na plus, compare it to you bigger in size. Okay, and next K plus, compare it to this one very bigger, and next is CS plus, so this is having very bigger picture. Now I told you very most important, small should be what? Cation size. Okay, large should be what? Anion size. So but comparatively smaller is Li plus, smaller in size, compare it to Na plus, then K plus, then CS plus. So this is the order of size, and simultaneously as the size is decreasing down the group, for increasing down the group, we can say this is not order of size. This is the order of covalent character. This is order of covalent character. The covalent character is an order, then this will be the order for these species. I hope you all guys understand this one. Next one is pseudo gas configuration. Next one is pseudo gas configuration. Gas configuration. So what is pseudo gas configuration? So pseudo gas configuration is very simple. Let's suppose copper plus, that is Ar 4s1 3d 10, but now 4s will be gone. Now you are having what? 3s2 3p6 3d 10. So now if you add all of them, you are getting 18 electrons. 18 electrons in the valence cell is called as what? Pseudo inert gas configuration. What is that? Pseudo inert gas configuration. I hope you all are guys understand this one. Now next one is NaCl. So in NaCl it will form Na plus. Next one is CuCl. So it is always form Cu plus. So now among these two, which is having more covalent character? Yaad rakhna, pseudo it will have what? Pseudo configuration will have more covalent character. So that is what? CuCl will have more covalent character than NaCl. Okay, which is having pseudo character will have more this one. Okay, I hope you all are understanding this one. What is pseudo inert gas configuration? Next, another most important one, last but not the least. Okay, we are talking about dipole moment. We are talking about what? Okay, so where it will get delta positive charge and delta negative charge, because the shared pair of electrons are shifted towards fluorine. Okay, na? So let me turn off the video, guys, because there is poor internet connection. Okay, poor internet connection. So now this is how the dipole moment. I told you. So the electron cloud is shifting from hydrogen to fluorine. So this is the direction of electron cloud, and the cross indicate positive terminal, head indicate negative terminal. Okay, the positive indicate positive terminal, negative indicate negative terminal. So what these are? These are called as partial charges. These are called as partial charges. These are called as what? Partial charges. Now, how do you calculate the dipole moment? So whenever if you see any electronegative atom, if that is having some directional properties, so that is called as dipole moment. The moment of the dipole due to the presence of an like we can say that more electronegative species. Correct. I hope you all guys understand this one. Okay. Right. Now how do you write the dipole moment of HF? You are going to write like this. Next one, if I am writing for the BeCl2, how do you write the BeCl2? Beryllium is here, chlorine is here, and another chlorine is here. So between beryllium and chlorine is more electronegative. Chlorine is more electronegative. So now we can say that there is a pull towards the chlorine, boron will be like this. There is a pull towards copper, the copper will be like this. So now both are in opposite direction and they are in same plane. They are in same plane and the bond strength is same and the bond strength is same. So then the net dipole moment will become 0. So this is 2 bond pair, 0 lone pair case. Okay. So simultaneously, if I'm writing for BF3, very most important. So for the BF3, boron will exist like this. Okay. So the boron will exist like this. The bond angle is 120 degrees. Now the question comes here. So this will, fluorine will pull on the top and this will pull on the bottom and this will pull on the bottom. Now you want to know the dipole moment. How do you find the dipole moment here? How do you find the dipole moment in this case? Pretty clear, right? So the dipole moment is simply nothing but resolving. Let's suppose this is A and B. Now resolving A comma B dipole moment. So whenever we are resolving, how do you resolve? The distance between them is x and x. The electronegativity also will have some x. So now dipole moment is always calculated as charge into distance of separation between them. Charge, normal not charge, charge, that is magnitude of charge. Okay, so the magnitude of charge into displacement. Okay, now you can see that this is Q plus or minus into D, distance between them. So let's suppose if this is A delta plus and B delta minus, so the distance between them is x. Okay, so that is x we are going to use. Now if you are finding the dipole moment for this compound, for two vectors, and dipole moment is a vector quantity. Dipole moment is a vector quantity. How do you calculate this one for the dipole moment? Okay, so dipole moment now can be calculated by using the nu1 square plus nu2 square plus 2 nu1 nu2. So this is what, and dipole moment is nothing but calculating the among the species where there is 16 of electron takes place. Jahan 16 of electron, there you have to put the particular thing. Now if you see this one, the bond angle is 120 degrees. Yes, so that is cos 120 degrees, is nothing but minus 1 by 2. And you know that the length is same between them. So that's why x square plus 2 into, okay, 2 into 1 we have 2x1 x, okay, 2x into cos theta. So theta is simply nothing but 120 degrees. So if you keep that one, so if you keep dipole moment is equal to under root of x square 2x square into cos theta. So here theta is 120. This is also dm is equal to dipole moment is equal to x plus 2 into x square into minus 1 by 2. Minus 1 by 2 cancel, x square and x cancel. Then under root of 2x x plus this one. So 2x square. So 2x square का ये हो जाएगा cancel, and this is x square, not x square. Okay, x square minus y square, and this is coming like this. So then at the end you are going to get x square and x. So now we whenever the bond angle theta and 120 degrees, and if you are given to, okay, the bond angle is 120 degrees, and if you are ये है और then this is also okay, then no check of dipole moment, it is the dipole moment. So the dipole moment will be in the middle. Okay, so that is how you find the dipole moment. So we have seen the bond angle, bond strength, and then covalent character, and then dipole moment. Okay, so dipole moment by both are correct. Dipole moment help in the polarity. How dipole helping in polarity? Because this is a charge transfer phenomenon. So due to charge transfer phenomena, so let's suppose if you see HCl, so this is delta plus and delta. Sometimes what you see that these kind of charge separation is simply nothing but polarization. Okay, this charge separation between them is simply nothing but what? Polarization. So polarization is simply calculated as we can, not polarization, polarity. Okay. Next, non-polar compounds. Now I am going to find the non-polar compounds. So there is a short trick for this one, which is very easy. So for the non-polar compounds, okay. So for the non-polar compounds, usually polyatomic species. Okay, I want to see the atomic species. What are polyatomic species? CH4. Okay, SO6, PCl5, SF4. These all are things. Okay, CF4, SF6, PCl5, and SF4. These all are there. These all are polyatomic species. And you want to know which them is which are them are, we can say that having polarity and non-polar. So usually non-polar homoatomic atoms. N2, O2, okay, Br2. Routine life, but routine life, this is not going to, we can say that H2O2, N2, and Br2 homoatomic, which is having same number of atoms, which is having same number of atoms. When there is same number of atoms, okay, and the atom is similar, you can say this will show the dipole zero. If the dipole moment is zero, then usually they will have a symmetrical structure. And next one, they are non-polar in nature. They are non-polar in nature. I hope you guys understand. Okay, homoatomics are non-polar. And the next one, very, very most important, bond pair and lone pair. Bond pair is 2 and lone pair is 0. 3 and 0. 4 and 0, 5 and 0, 6 and 0, 7 and 0. If the bond pair is 0 and the lone pair 7, 6 like that, then ideally the dipole moment will be 0. And these all are compounds are non-polar compounds. Simple सी बात है, just remember this thing. The bond pairs are 2 and lone pairs are 0. For example, you can take PeCl2. And another important thing, you it as a star, the side atom should be same. The side atom should be same. The side atom should be same. Okay, so now let's suppose 3, 0. That is BF3. So BF3, if you see, so this is bond pair and this is lone pair. Now, how do you see the dipole moment in the BF3? So now let's suppose boron is there, fluorine is there, fluorine. Sorry, we are having 3 only, right? We are having only 3. So now this is, we are having 3. So now this is 120 degrees. Now if you resolve them, if you resolve 1 and 2, you are going to get a perfect vector which is having x. And if this is x and this is also x, both will cancel. The dipole moment will be 0. I hope you all guys understand. Again, I am writing here bond pairs and the lone pairs. 2 bond pairs, 0 lone pair, 3 0, 4 0, 5 0, 6 0, 7 0, which are having symmetry, where the dipole moment is 0. Where the dipole moment is 0, we can also call it as non-polar molecule. You can also call it as non-polar molecule. Non-polar molecule. Okay, that is non-polar molecules. So some of the non-polar molecules are, we can also say 2, 3, 4, 2, and 5, 2. So this is also bond pairs. This is also lone pairs. So bond pair, lone pair, bond pair, lone pair. If they are in this number, again their dipole moment is 0, and they are not getting non-polar. They are coming non-polar. Why? Just take the example of XeF3. So you can take the XeF3. Okay, xenon, fluorine. Let's suppose 3 fluorine, right? So total 5, no? So XeF2, if you take 2 bond pairs, no? if I am taking about XeF2, I'm so sorry, XeF2, that is fluorine, xenon, and fluorine. So the bond angle is 180 degree, and the bond moment is 180, 180, and 180. Three 180 are there, so they will try to repel with each other, and they will become stable. So now we can say that F, XeF. So what is the bond angle? 180 degrees. Okay, so the bond angle is 180 degrees, and this is also non-polar. This is also non-polar. Okay, I hope you all guys understanding this one. Okay, so this is what non-polar. Next one is polar. So very most important is polar compound. Next one is polar. Polar. How do you decide a polar? Where the dipole moment is a non-zero. Next example can you give? Yes, if you take CH, what is going to happen? Carbon, chlorine, 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 and hydrogen. Okay. So if you can see, the electron dipole moment will be that side, this side, and the dipole moment will be this side. So there is very less impact of these dipole moments. So which is, we can say that this is a non-zero dipole moment. So then this is a polar molecule. This is polar molecule. Simultaneously, if you take CH2Cl2, CH2Cl2, again it is a non-polar molecule and it is having this. Okay, for N2, C2, or CO, all these all are non-polar. Okay, all these all are non-polar in nature. Okay, na? So next one, some of the other examples you can take, like NH3 and NF3. If I'm asking which is having dipole moment is more, किसके पास dipole moment more है? Many people will say that NF3 will be more because fluorine is more electronegative, but na, this is wrong. Okay, so NH3 will have more dipole moment than NF. Okay, so that's it, guys. I hope you all understand this one. Okay, so I'm feeling a bit headache now, so I can't continue the class. I will give some of the examples, then I will leave the class. Let's suppose let me take some for other 5 minutes. Some of the examples. Find the molecules or compounds, polar or non-polar, polar or non-polar. Let's suppose if I'm taking like this, chlorine, OH, C triple bond N, C triple bond N, okay, SH, and try to find whether the compounds are polar or not. Now, yeah, so now see here, this is chlorine and this is chlorine. So chlorine will pull up and this chlorine will pull up. So both will cancel. So the dipole moment is 0 and it is a non-polar. The dipole moment is 0 and this is a non-polar. Now you can see. Oxygen is there. Okay. And next one is here, oxygen is there. Okay. So now many people will think that this will pull and this will pull. So symmetry, and that's why the dipole moment is 0. No, absolutely wrong. Here you can see the structure here. If you draw the structure properly, okay. So because of lone pair, what is going to happen here? There is a loss of symmetry. So we will hear this loss of symmetry in your class 12 also for the John Taylor effect. We will discuss that one later. So now due to the lone pair repulsions, so the bond angle is decreased and this is non-zero. And this is non-zero and this is taken as non-polar. Okay, right. Next one, cyanide you can say. So next you can say C triple bond N and C triple bond N. So in C triple bond N, this will pull this side and this will pull this side. The net dipole moment is non-zero. So sorry, it is 0. Dipole moment is 0. Then this is a non-polar molecule. Then this is non-polar molecule. I hope you all guys understand this one. Okay, polarity and non-polarity, and some of the other important terms for the chemical bonding. Some of the other important for the chemical bonding. I am writing here. Remember and please do read. VSCPR theory is must. Homework I am giving you guys. Find which is polar and which is non-polar. आपको find करनी है which is polar and which is non-polar. Okay, which is polar and which is non-polar. VSCPR theory, hybridization is there. Okay, VSCPR theory, Pseudogas rule, or we can also say that covalent character, ionic character wala, Pseudogas rule, covalent character. And the fourth one, okay, MOT theory, and the fourth one is MOT theory, very most important. So the bond order is directly proportional to bond energy and inversely proportional to bond length. So if you can do this one, then you can easily understand. Okay, so just do the 4 or 5 practice questions, and I hope you all guys understand this one. Okay, so again I'm taking some other one notes. Yeah, so very most important thing is dipole moment. Okay, clarification is really important. For that you need to do repulsions. Next is hydrogen bonding. What are the type of hydrogen bondings? You know, 2 types. One is inter and another one is intra. So what is inter and what is intra? So let's suppose if you are having CH3F, so you are having another bond with CH3F. So this kind of networking is there, right? So this is inter. Inter means between other molecule. Intra means what? So let's suppose if you are having, okay, so the bond formation between these 2 atoms, and this is intramolecular hydrogen bonding. This is intramolecular hydrogen bonding. Okay, so this is what you people need to remember. And homework for you from here is like homework. What is the boiling point? Kiska zyada hoga, and what about the melting point? Iska ye hoga, and color. Okay, so color iska to nahi rahega. Melting point and boiling point C for the case of hydrogen bonding. Okay, I hope guys you all people loved it. Okay, thank you so much for joining the class. We will see you in tomorrow's class. Bye have a nice day. I'm feeling a bit headache, so that's why I'm ending the class a bit faster. Okay, sorry guys. Yeah, thank you. I'm feeling a bit headache, so that's why I'm leaving class early, 3 minutes before.